Hello everyone! Hope your weekend's going good so far. I know mine is. What I'd like you to do is go ahead and have a calculator handy for this section of notes. We are going to be doing something that is pretty calculator intense. So let's jump right into it. I don't want to waste any time here. The steamboat problem. This is going to be more on the not so simple harmonic motion stuff. It says Mark Twain sat on the deck of a river steamboat. As the paddle wheel turned, a point on the paddle blade, moved in such a way that the distance d from the water's surface was sinusoidal function of time. When his stopwatch reached 4 seconds, the point was at its highest, 16 feet above the water's surface. The wheel diameter was 18 feet, and it completed a revolution every 10 seconds. So here's what's going on. If you've never seen one of these steamboat paddles, they've got this series of paddles on the back here. And what this is saying is that the paddle is on a point here, it's rotating around, and on that same blade, it's just following what's happening here. So you can kind of imagine it like this. Let's say that you've got a wheel, you've got your paddle wheel, this is looking at it from the side, right? And it's got all these blades on it, right? It's got blades going everywhere. What this is saying is that the blades go underneath the water, obviously to push it forward, right? And it says that at a maximum, it reaches 16 feet above the water's surface. So it's going to go up here to 16 feet above the water's surface, right? 16 feet above the water's surface. So the wheel's diameter is 18 feet. The whole distance here is 18 feet. So that means that it goes down 2 feet below the surface, right? If it's 18 feet. So the surface here we're just going to call 0. Okay? And then it says it completed one revolution every 10 seconds. And we started 4 seconds, right? 4 seconds was a high point. And then it completed a revolution in 10 seconds. So a couple of things here. Your amplitude is going to be your highest point, 16, minus your lowest point, -2, divided by 2. So that's 18 divided by 2, which is 9. So your amplitude is 9. Your K value is going to be 16 minus your amplitude, which is going to be 7. Your period here, it says it completes a cycle, one revolution every 10 seconds. So P is 10. So B is going to be 2 pi over 10, or just pi over 5, right? All important stuff to know. So just using that information, I'm going to come over here and I'm going to graph it. All right, so T is going to be on your x-axis. This is T, and this is in seconds. This is going to be D, the distance from the water. Distance from the water, and this is measured in feet, right? So your distance from the water, so this is 0, this is the surface of the water here. So a couple of things here. It says that at 4 seconds, you hit a maximum, and your maximum is 16, right? And then at 10 seconds later, so now we're at 14 seconds, we should be one cycle over, another maximum. So halfway in between there, we're going to be -2, we're going to be 2 feet below the surface. All right, we got our little wave here going on. So halfway in between that, your K value was 7. So imagine halfway in between this thing. Your K value here, when you do it this way, K is going to equal 7. Right? So a couple things going on. Halfway between 4 and 14, right? So 4 plus 14 divided by 2. It's going to be 9, so this value is 9 right here. There's a minimum. Okay, so it says write an equation for the function. So we've got f of t. Your amplitude is 9, right? This is starting on a maximum, so it's going to be a cosine function. B is pi over 5. We're going right 4, and we're going up. Your k value is 7. Okay? All right, so a couple of things here. It's going to ask us some questions. Move this up so I can see these. Back off just a hair. It says, how far above the surface was the point when Mark's stopwatch read 5 seconds? So that's simple enough. All I'm going to do is plug in 5 seconds into my calculator, into x here. Excuse me, this should have been an x. What am I doing? I keep getting that backwards for some reason. So I'm going to plug in 5 seconds for t, for your time. Make sure when you plug this in the calculator that you put your parentheses. This is the one the calculator opens, so you have to close 2 of them. All right, now just for the sake of time, because the second question is going to take a while, I'm going to move on. I've already got these done up here. This is going to be 14.281 feet. And then you plug in a 17 in there, and you get 4.219 feet. Remember, always 3 decimal places. That's just plugging in 17 and 5 for t. What is the first positive value of time at which the point was on the water's surface? Okay, so this one is going to be a little bit different. I'm going to go ahead and enter this into my calculator here. This is going to be 9 cosine of pi over 5 times x minus 4, close 2 parentheses, plus 7. My window needs to go from 0 to 14. My y min needs to go from -2 to 16. There's my graph. Let it graph. And it wants to know what was the first positive value of time at which the point was at the water's surface? Which the point was at the water's surface. So the first time it dips into the surface is going to be right here. Right? Now this is after he started recording. Did it dip in back here, though, is the other question we need to answer. Did it dip in back here? So the way I would tell that is go to 0, hit trace, and go to 0 for x. See how your y value is negative? That means you did, in fact, cross the x-axis. So here's what I'm going to do. Zoom 6. Check this out. See that right there? That's the first time that's a positive value when I'm at the water's surface. So let's figure that out. It's going to be a 0, so second trace. Just watch with me on this one. 2 for 0. I'm going to go left of the 0. This is the place I want to find. Left of the 0. Hit enter. Go right of the 0. Hit enter and enter. 0.082 if we round up. So 0.082 seconds. And at that time, was it going into or coming out of the water? This is coming out of the water, right? It's going up. So it's coming out of the water. So we're coming out here. Coming out of the water. And you know that because f of t, the function, is increasing. Okay? So, pretty basic. The only difference now is that it's going to be a little off because we're working with something traveling beneath a surface. We're going down 2. Okay, so let's go on the back here. This is where things get interesting. This is actually how we do this stuff IRL. I don't know if anyone says that anymore, but in real life, this is actually how we do this kind of mathematical modeling, and this is the point I wanted to focus on. So it says the average monthly temperatures for Houston are shown below. whoever put these temperatures in obviously has no clue how hot it gets in Houston in July. I'm sorry, 82, that ain't no way. But anyway, I digress. We'll fix that later. Let's just say for kicks and giggles, these are the actual temperatures. Okay, so it wants to enter the data into your calculator and view a scatter plot. Use t equals 1 for January. You're going to have to pause quite a bit on this. I hope somebody's listening to me up there. You're going to have to pause quite a bit on this just to catch up because I've already done it to save us some time. It wants us to enter our calculator, enter the stuff into our calculator, right? So I'm going to get out of this, clear that out. I'm going to go to stat, this little button right here that says stat. Hit stat and edit, number 1. And I have already entered this information. We're entering in this stuff, so January's, oh my gosh.
April Murphy.
January is 1, down through December is 12. So I entered 1 through 12 on the list 1, right? And then in list 2, I entered their corresponding temperatures all the way down. So pause the video right here and do that. All right, and once you do that, it says, view a scatter plot. See that? View a scatter plot. Here's how we do that. Go to y equals. Clear out anything you have in there right now. See plot 1? Turn that sucker on by pressing enter. I just went over. All right, I scrolled up, pressed enter to make sure it's highlighted now. And I'm going to need to change my window if I want to see this. So my X's are judging months. So that's going to need to go from 0 to 12. There's 12 months. Your Y min can go from 0 to the highest temperature was 82. So let's just bump it up to 90 so we can see the whole graph. Hit enter. And points! Yay! There's points there. And then it wants to find the regression model for the data. If you didn't get that, pause it, rewind it, go back and do it. B says find the regression model for the data. I would like you to write down the steps right above this for how I'm about to do B. Follow along. The regression model, press stat. Go right to calculate. Scroll down to letter C. It says sign regression. Sign regression. Again, to see that one more time, that was the stat button right here. Stat for statistics. Right for calculate. C for sign regression. Press enter. See it's blinking? Press enter again. Rewind it, do it again if you need to. It says y is equal to a sine bx plus c plus d. It just gives you a, b, c, and d. This doesn't necessarily mean the same thing our b does. These are just placeholders for these numbers in this equation. A is 16.770, b is 0.480, c is negative 1.841, d is 66.500, 0.501 will do. If you did not get this, rewind, go back, and do it again until you get this. I'm going to come up here and I'm going to fill in that equation. Y equals A is 16.770 sine of 0.480 x minus 1.841 plus 66.501. That came from here with this regression done up in here. Put A where A is at, B where B is at, C where C is at, and D where D goes. Okay, it's pretty basic. Write your equation. And then we're going to take this guy and we're going to graph that. So I'm going to go to Y equals, go to Y1, and I'm going to plug in this equation. There is a way to stow that. I don't know it, but there is a way to do it. Or I'm doing it in Y2. It doesn't matter as long as nothing else is in there. Sine of 0.480 x minus 1.841, close parentheses, plus 66.501. Graph it, and check it out. It actually goes through my points. A regression is throwing your data into a computer and saying, make a model out of this. It's also called the line of best fit. So, graph the model. How well does it fit the data? Well, it fits it pretty darn well, don't it? So we call that a very good fit. D says, what is the average annual temperature based on the model? Cool thing about the sine wave is that the horizontal axis is your average. So K, this guy, is your average. 66.501 degrees Fahrenheit. It says, what is the range of temperatures from the model? Now this is from the model, right? This is not going off of what I have over here. This is from the model. So what I'm going to do is find a maximum. Let me go in here and I'm going to turn off my plots. Hit graph. Again, that was just highlighting the plot, pressing enter. I'm going to find this maximum over here. I'm going to go to second, calculate, and max. Again, if this is going too fast, stop and rewind it. I want to find this maximum. You can't see it because the equation's covering, but it's right here. It's asking for the left bound. I'm to the left of it. Hit enter. Right bound. I'm going to go to the right. Go, 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 go. There we go. Hit enter. Guess. Sure, why not? Hit enter again. My maximum is going to be 83.271. Let me write that down. 83.271, right? My minimum, I'm going to need to zoom out a little bit here. Zoom, 3, enter. My minimum value, y value, I just need to pick any lowest y value I can. Second trace number 3 for minimum. Go to the left of a minimum, go to the right of a minimum, hit enter and enter. Minimum is 49.731. So I should have actually written it the other way. 49.731 to 83.271. That's my range. Not too shabby. It's the lowest y value to the highest y value. All right. According to the model, what is the average temperature in September? So that's easy enough. I'm going to hit trace, and I'm going to go to September. Trace, go to September, which is 9. 76.817 degrees. 76.817 degrees. You may get something that's slightly off of that because every calculator is going to round a little bit differently when they do regressions. But as long as it's within a degree, you're going to be okay, within 1 degree up or down. When is the average temperature above 75? You know how to do that. I'm going to do this very quickly. Let's go back to our original window, 0 to 12 and 0 to 90. It wants to know when the average temperature is below 75, so plug a 75 in here. And then find these two intersection points, this one and this one. Now I've already done that just for the sake of time. If you don't remember, it's second trace 5, enter, enter, enter. There's the first one, 4.942. So it's going to be 4.942, and I found the other one at 9.264 months, and T is somewhere betwixt them. So it's late April to early September, right? And that's all she wrote. I would highly recommend, if you missed anything on the calculator, go back, do it again, get it done before you get to class on Monday.